I've made another find while I was digging through some old electronics I have. In this case, this is a Parallax text-to-speech module. So just from looking at the interface, it looks pretty easy to work with. I mean, it just has 5-volt power input, a 96 baud serial interface, and there's an earphone jack. So I'm going to see whether or not I can get this to say something. I went ahead and dug out one of my Arduinos, and I'm going to see if I can get this up and running. I imagine it's not going to be too hard. I'm not sure why I've had this sitting around so long without having used it. Let's see how easy it is to interface to this. So I have the device all wired up, and it only really took 4 wires to connect it. 2 of the wires go to the Arduino's 5-volt and the ground, then 2 of the other wires are being used for a serial port, and I'm using an Arduino software serial port. The last 2 wires that are on the device are for connecting a speaker. Now there's also an earphone jack on it, so that's how I'm going to be connecting to it. But that's all that it takes as far as wiring goes. Setup is simple. The only thing that you really need to do is to configure 2 of the pins as input and output so that you can have a serial connection to the device. Following a code example that came from Grand Idea Studio, I did also go ahead and configure pin 13 as an output. That way, whenever the device is speaking, you can turn the lid on or off so that there's also some type of visual status that something is going on. That can be helpful if there's something wrong with your audio, such as it's muted, so that you can at least see if it's attempting to speak. As you can see from the code comment here, the device itself takes about 3 seconds to boot up. And once it boots up, it will send a colon to indicate that it's ready. Now here, the code example sends a new line character to the device because if it is already booted up and ready, then it's just sitting there waiting. But if you send a new line character, then it will send a colon in response. So once that happens, the buffer's flushed and it's ready to go. Now I did go ahead and wrap some of the other settings inside of other methods. There's 2 different parsers that this can use, and I'll talk about those in a moment. The most commonly used series of commands is encapsulated within the function speak and wait. What this will do is it will send the command for speaking, which is the character S, followed by the string that you'd like for it to speak, followed by a new line character. Now the device can accept strings of up to a total of 124 characters long. If you have anything longer than that, you need to break it down into something smaller. So you can see when it's speaking, I go ahead and I turn the pin 13 on, and then I wait until the device sends another colon. Once it sends one of those, you know that it's ready again. I start off sending the device a reset command. Doing this will get the device in a known state and select all of the defaults. The most commonly used command after that is a speak command, and a speak command is just the capital letter S, followed by whatever string that you want it to print, followed by a new line character. Now, the total maximum length for anything sent here is 1023 characters. If you have anything longer than that, you're going to need to break it up. The device has a total of 9 voices that can be used for speaking, and the voice command is just the letter N followed by the ASCII character for the voice, which is a digit between 0 and 8, followed by the new line character. The device can speak as slow as 75 words per minute, and it can speak as quickly as 600 words per minute. So to set the word rate, you just send a W followed by a number between 75 and 600, followed by a new line character. By default, the device is going to use a straightforward and pretty simple parser for the English that you send it. And that's the quickest and easiest to use. Now, if you want to control more as far as how it sounds and the pitch and how long each syllable lasts, you can select a different part. You can select the duck talk parser. If you select that, you have to send everything to it phonetically. Now, when I went through the documentation, they did actually have the happy birthday song spelled out in a way that this parser would be able to consume. So I'll let you hear how that sounds.
Cool. I got this thing working. Let's see how this sounds. Paul is test voice 0. Huge Berry is test voice 1.
Beautiful Baby is test voice 2. Ursula is test voice 3.
Dr. Dennis is test voice 4.
Kid the Kid test voice 5.
Frail Frank test voice 6.
Rough Rider test voice 7. Whispering Wendy test voice 8. This is the lowest word rate. This is the fastest word rate.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Emmett. Happy birthday to you.
Overall, this is a pretty easy device to use, and it looks like it would be a quick way to add a voice to any project. The only thing is, I'm not recommending this. I just dug this. I found this in a box, and so that's why I'm showing it. But I also tried to see what I would need to do if I wanted to get another one. And right now, the prices on these things are, dare I say, a little outrageous. I don't know if that means that they're out of production, or if that's some side effect of the chip shortage, or what the problem is. But if you're able to get one cheaply and you just want to quickly add a voice to a project, then it might be a way to go. Otherwise, it might be easier to get a Raspberry Pi Zero. See if you can find some text-to-speech software for it and configure that to be used as such a device. Because right now, that looks like it might be cheaper. I looked up the schematic for this device, and there's really two significant components on it. There is a CPU made by NXP, and there's also an audio DSP. Now, I was looking at these with the question in mind, how easy would it be for somebody to replicate one of these? But after I looked up the specs for the processor, I realized that this is not as much of a hardware solution as I thought it would. There's also significant software components. So even if someone were able to replicate this hardware, without the software, the replication wouldn't really be of much value. So I think this makes for an interesting device, and I think I'm going to use this for something, but I wouldn't use it for something that I need to replicate simply because I don't know if I'd be able to get another one of these.